This conference will now be recorded.
Very good morning, students. We have been discussing POIQs from JEE Mains papers. Today, we'll be completing the question paper JEE Main 2021, 26th August shift 2 paper. We have the last few questions remaining with this paper. So let us start our discussions. So this is very common question you see in the screen from the semiconductor chapter. So this is with Zener diode, and this particular circuit is very important circuit. This is actually, as you know, Zener diode is used as a voltage regulator. Okay, voltage regulator. That means at the breakdown region there will be change in the current very rapidly, but voltage across the Zener diode will not be changing. So that's how the voltage across the Zener diode, which is exactly equal to this RL, the load resistor over here, can be used as the stabilized voltage input. Okay, all right, so look this question. So this question says, for the given circuit, the power across Zener diode is dash milliwatt. So you have to find out power across Zener diode. That means PZ. So PZ I can write, see, V you know already, VZ you know. So VZ into IZ. So what is the main problem now? The problem is to find out what is IZ, that is the current through the Zener diode. So how to find out that? You look here, as I said, voltage drop across this RL and VZ are actually equal. So you can see here the total current which is passing through this 1 kilo ohm resistor, let us say that is IS, and that IS is equal to IZ plus IRL. Okay, so this IS is actually divided in these two branches. One is IZ, which is passing through the Zener diode, another one is IRL. So finding out IRL is very easy, as you know, because the voltage drop across this RL is same as the VZ, that is 10 volt. Okay, so let us find out what is IRL. Then 10 volt by RL. RL is 5 kilo ohm, right? So 5 into 10 to the power 3 ohm, that means, you know, this is 2 milliampere. Okay, so that I have got. Now what is IS? How do I find out IS? See, this particular circuit is actually this is very fine, but this circuit can be drawn in another way also. Look, if you can understand this. So this is my RS, this is my RL, this is RL, this is RS, this 1 kilo ohm, and there will be Zener diode connected at this. Look, now you might be able to understand what is the current through this RS. See, if I just consider this particular circuit, look, voltage drop across this RL is 10 volt given. Okay, as I know VZ. and here I have got 24 volt. Okay, look this figure. This particular figure will tell you how to find out IS. So IS will be, see, 24 volt minus the voltage across this resistor, that is 10 volt, divided by excuse me, excuse me. I'm sorry. So now this is 1 kilo ohm. Okay, so this will give you some 14 milliampere. Now from this equation, can you find out the IZ? Answer is yes. IZ is equal to IS minus IRL. I know what is IRL. That is 2 milliampere and IS is 14 milliampere. So this will give you 12 milliampere. So I have got IZ. Then what else I need to find out power across the Zener diode? This VZ is 10 volt, IZ is 12 milliampere. So this will give you milliampere, sorry, milliwatt. 10 to the power 3, let me write 10 to the power 3 here, 10 to the power minus 3. So this will be in a watt. So you look here, 120 10 to the power minus 3. If I keep this, so this will be actually 120 milliwatt. Okay, sorry, milliwatt. 120 milliwatt. So the answer is 120 milliwatt. So dear students, you have to actually carefully do this problem and try to understand. This problem is very, very important for many competitive exam, not only NEET or not only JEE Mains. Maybe you can come across this problem in any competitive exam. So try to learn it. All right. So sometime sometime you might be given what is IZ. Then you have to find out what is the current, or sometime the current, the total current passing through this resistor will be given. Okay, IZ will be given. Then you have to find out what is the possible or the maximum series resistance you can use, RS, in the circuit. So those things are there. Actually, if you go to the laboratory, you will be given the power of the Zener diode. You will not be specified this series resistance. You will be given this Zener diode. You will be given this RL, but you have to calculate this series resistance in the laboratory, while PZ will be given to you. Okay, that means you will be able to find out what is the current across the Zener diode from P. Okay, and the voltage drop across the Zener or Zener breakdown voltage will be given already. So so by that way you have to find out what is RS. All right. Now let us try to solve the second problem. This problem is also very interesting. You can see here there are two waves. So two waves are simultaneously passing through a string and their equations are given. So this y1 and y2, there are two waves which are simultaneously passing through a string. Given a1, a2, x0 and wave number is given. The amplitude of the resulting wave will be dash millimeter. So you have to find out the amplitude of the resulting wave. So first of all, you have to use the superposition principle, as you know. So y is equal to the displacement produced by both the waves. Okay, so that will be additive. Okay, so let us just do this. A1 sine k x minus vt plus a2 sine of k x minus vt plus x0. So you can see here this term is common in both the cases. Only this x0 term is k into x0, I would say. K into x0 is extra over here. So just what we have to do, we have to bring this whole thing in terms of one sine or cosine. Okay. If we can do that, excuse me. So if we can do that, then we'll be able to find out what is the actual amplitude. Okay. So let us see, this part is all right. I'm not going to break this. Okay. So a1 sine of, sorry, this k will be there, x minus vt. Let this be as it is, but this term I'll just use this sine of a plus b, this trigonometric identity. Okay, so this I'll just take as a, this I'll take as b. So sine a cos b sine k x minus vt. Okay. At the same time cos k x0. Okay, so sine a cos b plus a2 cos a sine b, cos of this cos k x minus vt sine k x0. Right, now look, this is whole term. Here you have got this term. So I can do one thing, I'll just take this sine k of this term common, so that I have only one sine term, where I have to get, see, a1 plus a2 cos of k x0. Okay, this is kind of amplitude term, I can say. And here, see, this term, let us say this sine a2 sine k x0 cos of k x minus vt. Okay, so sine a cos b, like sine and cos. Okay, let me just do it here. What I have got, y is equal to I have got a1 plus a2 cos of kx0 sine of kx minus k. Okay, so k, let it be out. X minus bt and plus of a2 sine kx, a2 sine kx0 cos of k x minus bt. Okay. So I have got this term similar. So if I consider this particular term a1 plus a2 cos of kx0 as cos of phi, okay, and let us say, sorry, a cos of phi and a2 sine k x0 as a sine phi, okay, then this equation will be y is equal to, see this I have taken, this whole thing I have taken a cos, so a cos of phi sine of x minus bt plus a sine phi cos of, sorry, k will be there x minus bt, right? So I have to find out what is this a. A is the amplitude. Then see, I have got now the whole this displacement to be a sine a minus a plus b. So a plus b means x minus vt is a and phi is b. So this is my whole displacement, okay, resultant displacement. But now we have to find out what is this phi and what is this a. So what is this phi? I can find out what is phi. So tan phi is equal to, okay, tan phi is equal to a2 sine kx0. You can go with that a1 a2 cos of kx0. You can go with that, or otherwise you can go with some other way also. Let me just not worry about phi now. Let me find out what is the magnitude of this amplitude. Okay, but obviously I have to find out what is phi. So actually phi is, you know what is phi? Phi is phase difference, right? So phi will be always 2 pi by lambda into path difference, okay? Path difference, okay? So what is this path difference here? Path difference is actually x0, right? Path difference is x0, okay? So this 2 pi by lambda is actually k. K is the y vector, okay? And x is actually x0. Because you look here, if I write down, see, if I write down this thing is square is equal to, see, whole square of this plus whole square of this. So it's a1 square plus a2 cos kx square, and this will give you a2 square plus 2a1 2a1 this one into a2. Okay, this 2a1 a2 cos of kx0. Okay, I can write this kx0 as pi. So a will be square root of a1 square plus a2 square plus 2a1 a2 cos of pi. So pi means kx0. Okay, kx0 is the phi. So I can actually guess what is the phi in terms of pi. Let me put the values. You can see here the values of k and x0 are given. K is given as 6.28, 6.28, and x0 is 3.5. Okay, so this, if you just multiply this, I have to get in terms of pi. Okay, in terms of pi, let me write, see this multiplication, this will be something like 21.98 or something. Okay, so let me write some n into pi is equal to this 21 into this. So then if you just divide with pi, you will see this n will turn out to be 7. So 7 pi. So this value is actually equal to 7 pi. Okay, so kx0 will be actually equal to 7 pi. That means pi is equal to 7 pi. Okay, 7 pi. This is going to be 7 pi. So I have got this equation. You look here, a1 square plus a2 square plus 2a1 a2 cos of pi. So this will be actually, here this will be minus, see 7 pi means minus 1, right? So this is going to be, I'm writing here, let me clean this thing. A is actually going to be a1 minus a2 whole square. Okay, a1 minus a2 whole square. So this will be in millimeter, obviously. So this is 12 minus 5 whole square, right? That means this will be 7 millimeter. Okay, so I hope you have got this problem, like you have got this yeah, got the solution. What we have done, we have just used the superposition principle and tried to simplify the equation the way we know to find out amplitude. And then the tricky thing was this one. What was the tricky thing? The tricky point was here, what you write in terms of pi. Okay, otherwise cos pi, this particular point you may make mistake, or maybe you may come across some difficulties in calculation without calculator. Okay, so you have to, so whenever you get cos of pi some values, you just do one thing, you just write n pi is equal to this particular value and try to find out what is that n, so that you can make some progress in this calculation. Okay, all right. So this was also a very common type of problem which may be asked in the competitive exam, both in NEET or JEE Main. Okay, now we have another problem. This problem says a coil in the shape of an equilateral triangle of side 10 centimeter lies in the vertical plane. So you have sorry, triangle in the vertical plane. Let us say this is in the vertical plane, equilateral triangle. Okay, vertical plane between pole pieces. Okay, between pole pieces like this. Pole pieces means there will be N and S. These are electromagnet, pole pieces of the electromagnet. Okay, producing this pole pieces are producing uh, horizontal magnetic field of 20 millitesla. Okay, so like this. Some 20 millitesla. Okay, this B is 20 millitesla. All right. The torque acting on the coil when current of 0.1 ampere is passed through it. So in the coil now, if you pass some current I, so that I is 0.2 ampere through it, and its plane become parallel to the magnetic field. What is that? The torque acting on the coil when the current is 0.2 ampere is passed through it, and its plane become parallel to the magnetic field. That means, you know, you have your plane like this, plane of the triangle, and magnetic field is so, I'm sorry, not like this. Magnetic field lines are this. Now your triangle will be looking like this. Okay, plane of the triangle will be same. That means, you know, the magnetic moment, you know what is torque. Here you have to find out the torque. Okay, and that torque is given actually as root over x into 10 to the power minus 5 Newton meter. You have to find out what is the value of x. Okay, so this configuration, see, parallel to when the plane of the loop becomes parallel to the magnetic field. That means, you know, suppose you have a plane. Let me just take any normal plane. Okay, so if I take normal plane and uh, the direction of the plane will be actually perpendicular to the plane, right? Perpendicular to the plane, either rightwards or leftwards. You can take any way, because this is an open plane. Okay, so this will be actually the direction of the area vector of this plane. Now if this magnetic field becomes parallel to the plane, that means, you know, see, magnetic field is becoming like this. So basically the magnetic field and the area vector, or the normal to the plane, will be perpendicular to each other. This is the situation. That means the torque will be maximum. Okay, so let me just give you the expression for the torque. I hope you have already learned what is the torque. Torque is, sorry, m is the magnetic moment, mb, sine of angle between m and this b. So this sine theta, theta is angle between m and b. So b I know it is left to right, suppose, but when current is flowing through any loop, so using right hand thumb rule, you can find out what is the direction of this m. Generally, for any loop, it will be outward normal to the magnetic field will be magnetic moment will be outward normal to the uh, like it will be perpendicular. Actually, either it is outward or inward anyway. So it will be perpendicular to the plane. That means along the area vector of the plane. That is what I was saying you, that the direction of m will be, so if this is this will, if this current is in this direction, okay, the current is in this direction, it is flowing in this direction, then it will be actually coming out perpendicular to the plane of this triangle. Okay, if it is, see, if the direction is reverse, then it may be going in the reverse direction but perpendicular to the plane of the triangle. And when the plane of the triangle and the magnetic field becomes equal, the angle between these two will be actually, this m and b will be then 90 degree. Okay, so I can write the torque, maximum torque, to be mb. Now what is m? M is actually the current in the loop, area of the loop, into b. So I into a is actually m. So this is the whole problem. So what is torque? Now I'll clean this portion. What is the maximum torque acts on the triangle? That is I into a into b. What is I? First of all, this a is actually area. Area of triangle will be root 3 by 4 into a square, right? A square. So let us take this as meter. If a centimeter is given, so root 3 by 4 into 10 into 10 to the power minus 2 whole square. So this will give you root 3 by 4 into, see, 10 to the power minus 2 in meter square. I is given, I is 0.2, right? And this is root 3 by 4 into 10 to the power minus 2 meter square, and this is B is in millitesla. Ampere per meter square is actually again Tesla. Okay, so ampere anyway. So I a B is actually 20 millitesla. That means I can multiply 10 to the power minus 3. Okay, now look, then this this whole, all three will actually cancel each other, and so I get root over 3 into 10 to the power minus 5. This will be in nanometer, sorry, Newton into meter. Okay, Newton into meter. Okay, Newton into meter. You might be thinking how you are getting Newton into meter. See, I L into B, this gives you unit of Newton, and another dimension of L will give you Newton into meter. Okay, so in that way you can think of. So what will be the value of x? X value will be 3. Okay, value of x will be 3. All right, so let us go to the next problem. This problem is very, very interesting. Let us try to, okay, I think, yeah, I have, yeah. So this problem says the acceleration due to gravity is found up to an accuracy 4% on a planet. The energy supplied to the pendulum of known mass m. So pendulum has mass m, and energy supplied to it actually is given by the energy supplied to a simple pendulum of known mass m to undertake oscillation of time period t is being estimated. The energy has been estimated, okay, of a simple pendulum. Energy of a simple pendulum of mass m to undertake oscillation of time period t is being estimated if the time period measured to an accuracy of 3%, then accuracy to which E is known as dash percent. So look, first of all, the energy is written, or energy of a pendulum is mg L theta square by 2. Okay, this is actually the energy of a simple pendulum. Okay, now theta is the displacement, as you know. Okay, arbitrary displacement, and we know time period is equal to 2 pi root over L by G, right? So from here we can write t square is equal to 4 pi square into L by G, right? So what is L from here? L is 4 pi square. I'm sorry, this is L is t square G by 4 pi square. Okay, so if you put it here, what I get? I'll get E is equal to mg theta square by 2 into 4 pi square, sorry, t square G divided by 4 pi square. Now see, there is no information about the accuracy in theta, only the accuracy in G and accuracy in T is given. So all other things I'll take as constant in this case. Okay. All right. So now I have to find out accuracy. Accuracy means, see, I have got E is equal to mg square t square theta square divided by 8 pi square. Okay. So I have to find out accuracy. That means del E by E, d by E. Okay. So considering m, theta, and this is obviously a constant term, so I can actually write 2g by 2 dg by g plus 2t, that is dt, 2 dt by t. Okay, so to find out accuracy in percentage, we will be using this given percentage, 4% over here, right? 4% in the accuracy of gravity, acceleration due to gravity, and 3% in the measurement of time period. So I get 8 plus 6, that means 14%. Okay, in the measurement of energy. So the accuracy to which E is known will be 14%. Okay, 14%. Now I have got another problem which is also very important, and this problem is actually from the kinematics part. Newton laws of motion. Okay, so the coefficient of static friction between two blocks is given. Okay, and the table is smooth. The maximum horizontal force that can be applied to move the blocks together. Okay, so in this case, when this is smooth, you know, to move these two blocks together, the force, maximum horizontal force, must be exactly equal to the frictional force between the faces, okay, blocks. So the static, actually this is called limiting friction. Limiting friction, okay, limiting friction, that is F max, that must be equal to C into A. Okay, now if we find out A, what is acceleration, that is F max by 3. Okay, then we will be able to find out the answer. Okay, so what is this frictional force between these two? Mu mg, right? Mu is given, so mu m g divided by 3. What is mu? Mu is given as 0.5, m is 1 kg, and g is 10. Okay, divided by 3, right? So what we get? I'm sorry. Actually, there is a small mistake over here. I'll just correct it here. This will be just a 1A, because the force which is like frictional force which is actually on this upper block, that has to be equal to this much. Okay, this uh, that has to be exactly equal to the force on this, okay, this side, so that this will not slips down. Okay, let me just make you understand once again. So look, when it will be pulled in the right hand side with an acceleration, say acceleration A, so what will be capital F, the horizontal force, that is 3 into A. But how to get this A acceleration? So to get that acceleration, we have to understand one more concept, that these two blocks will be moving together if the force due to this F on this okay, will be 1 into A, right? This much acceleration, this is the mass. So this is the force in the forward direction due to the force, horizontal force applied here if they are moving together, okay. So moving together means acceleration of both the blocks will be same. So that is the force on it, and that will be exactly equal to the frictional force acting at the interface on this particular block when it is moving towards this side. Like if there is a relative motion between 2 and 1 kg and 2 kg, then there will be this F max static friction. So this maximum static friction should be exactly equal to the force acting on that in the like forward direction, okay. So I can write this mu m is 1 into g is 10, okay. So from here I'll get 0.5 into 10, which will give you 5 meter per second square. So this is actually the acceleration. So what will be the force, maximum horizontal force? That is 3 into 5, that is 15 Newton, okay. So 15 Newton will be the force. So F equal to 15 Newton here. All right. So I think I have just missed one problem in between. Okay, let me write down the problem. Okay, the problem says, let me take red color. If maximum value of accelerating potential provided by a radio frequency oscillator is 12 kilovolt, the number of revolutions, then the number of revolution made by proton in a cyclotron to achieve to achieve 1/6 of the speed of light. Speed of light is dash, okay. So you have been given MP as 1.67 into 10 to the power 27 kg. Electronic charge is given 1.6 into 10 to the power minus 19 coulomb. This is for proton, that's why it is positive. And what else? Speed of light c is given as c into 10 to the power 8 meter per second. So these are the informations given. So you have to find out what is the number of revolutions made by the proton in a cyclotron so that it achieves energy such that its speed becomes one sixth of the speed of light. Okay, I'll just tell you what it is. See, whenever see, first of all, let me understand up to here. Up to here, let us understand. If the maximum value of accelerating potential provided by a radio frequency oscillator is 12 kilovolt, that means uh, a radio frequency oscillator providing 12 kilovolt potential difference to a proton. Okay, to a proton. Where? In the cyclotron. In the cyclotron. Okay, in the cyclotron. See, what is cyclotron? If you know the structure, see, it is actually having 2D shaped structure, right? Two Ds are facing each other. Okay, two Ds are facing each other. So this place there will be the RF frequency. So the potential difference between these two Ds will be 12 kilovolt. Okay, potential difference between these two. So every time the proton jumps from one D to another D, it will be accelerated by 12 kilovolt. So for a complete revolution or complete, yeah, for a complete revolution, it is actually accelerated by this RF uh, radio frequency oscillator twice, right? It is accelerated when it jumps from D1 to D2. Let me just give the name. Suppose this is D1 and this is D2. When it is jumping from D1 to D2, it is getting accelerated once. That means it is actually gaining energy here. And when it is going from D2 to D1, it is gaining one energy again once. Okay, so that means, you know, in a complete revolution, the proton gains energy how much? 2 into q into the potential difference V, right? This much energy the proton is gaining. Now I have to make equal this energy with what? So this is for one revolution. Let me take n revolutions. N into this much energy will be equal to the kinetic energy of the proton half m v square. That means, you know, c by 6 whole square. Half m v square. That is 1/6 of c. So this is what is the concept. Okay, here. So now it will be very easy to find out the value of n. Let me calculate that. So we know n into 2q into v. V is the potential difference, and this is half m c by 6 whole square. Okay, now from here I have to find out. See, m is given 1.6 into 10 to the power, sorry, 67 into 10 to the power minus 27, that I can write here 1.67 into 10 to the power minus 27. m. C square is 9 into 10 to the power minus 16 divided by 2 into this 36, and this side 1 2 will come here, so 2, and q is 1.6 into 10 to the power minus 19, right? And what is this v? V is actually 12 kilovolt, 12 into 10 to the power 3. Okay, now look what we are getting. So if I do approximation, this I can actually strike with this approximately. Let me do that for the time being, and then we'll analyze further. So this is like this. Okay, now let us see the powers. So you will have here 10 to the power minus 27, this, that means it is 11, 10 to the power minus 11 plus 10 to the power 19, and from here there will be minus 11, minus 3. I hope this is fine. Yes, this is 10 to the power minus 11, and this is going like this. Okay, so I have 19 minus 14, so this is 5, right? 10 to the power 5 divided by, you have 12 and 4, 6. Okay, so 12 and 16. This is, I think, this one. Okay, so here you have 10 to the power 5 divided by 192. Okay, so then you have to do this calculation and find out. So it will give actually nearly 520, I would say 20, yes, complete revolution. 520 complete revolution. Okay, since we have done a lot of approximations, I think let me do one thing. If we don't do this much approximation, then it will give you, let us not do this. Okay, let me just, for the timing, let me use the calculator and try to get it. 1.67 into 9, so this will be kind nearly this into 10 to the power minus 5, sorry, plus 5 divided by, I have to strike this, so we have, okay, so we have 2 to 4, 1.6 into 12, and also this 36. Okay, okay, anyway, you just do this calculation, it will be something like this. Okay, around some 534. I'll just leave you the calculation on you. You can just do this calculation. This is MP and this is the speed anyway. So with this, I'll stop it here for today. So thank you for your patience. Bye for today.